So the last lesson, we basically talked about the definition of probability, working out the number of favourable outcomes divided by the number of total outcomes, and that fraction being the number that we need to use to sort out what the probability is of different things. So what we're doing this lesson is we are going to make that a little bit easier by drawing out our sample space for us. Now, if you have done the homework questions properly, you may remember there was a multi-stage event which consisted of flipping a coin and also rolling a dice. And we worked out that there were 12 different outcomes from that scenario. Now, when we are talking about a coin toss, there's normally two options, heads or tails. And when we are talking about rolling a dice, there are normally 6 options. And what we can do with a table is create a table of our potential sample space which then tells us how many options there are in total. So we'll notice 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There are 12 options in total. None of these are doubling up. None of these share both a dice number and a coin toss flip, right? And so we can actually work out, if we were to work out the total sample space of tossing a coin and rolling a dice from a table, that the sample space is 12. Okay, so what we're going to do is, using different examples, we are going to create tables to answer our questions. Now, this question asks us about different cards placed in a box, and 2 are selected at random with replacement. Now, that's a key word here, because when we replace something, that means after drawing a red one, we could draw another red one, all right? And that's different from drawing a red 1 to then drawing the red 2. And again, that's also different from drawing the red 1 to our first black card there. Now, at this stage, we've only got 3 outcomes, but hopefully you'll be able to actually see a pattern, and why, if we order this pattern properly, we'll be able to actually solve our table. Now, the reason I've drawn a 9x9 box is after we have our first pick, we need to follow it up with a second pick. Sorry, it's a little messy. Now, after we've picked our red one, we could pick another red one, or we could pick the second red one, or pick our first black one. But these are the only 3 options that can happen from this table. So we're then going to go, okay, what happens if I pick a red 2 and then I pick the red 1, or red 2 and then the red 2 again, and then the red 2 or the first black one, and then we're going to finish off our table like so. So again, from our table we can see that the sample space is 9. Now, if we look at question B, question B asks us what's the probability of selecting R1, R1 and R2, R2. Now, out of all these, only these 2 there are the number of favourable outcomes divided by the total number of outcomes. Okay, so that is our probability. Now, how we write that again is probably R1, R1 or R2, R2, and that's kind of how we write it with our notation with probability. Now, tree diagrams are slightly different, all right? You just need to ignore this. So basically, this is a tree diagram of tossing a coin twice. Now, it's not tossing the same coin, all right? We're tossing 2 separate coins. Our first coin can either be a heads or tails, but our second coin also depends on whether the first coin was a heads or our first coin was a tails. And if we look at this table down here, we end up with 1, 2, 3, 4 outcomes. So again, here our sample space is 4. Now you don't explicitly need to write these sample space equals whatever, but the reason I do it is because when I'm creating a fraction out of my probabilities, this is always the number that's going to be at the bottom. Alright, so how we draw our tree diagram is we draw a diagram with each event as a new branch of the tree. And we always draw large tree diagrams and list the sample space on the right hand side. See how this sample space is listed here? Alright, so we could have gotten a heads heads, or a heads tails, or a tails heads, or a tails tails, like so. Okay, so when we are drawing a tree diagram, draw a tree diagram of a coin toss and a dice roll. Now, do you remember the earlier question before? We already know the answer to this question. Our sample space has to be 12. What we're going to do is we're going to draw a tree diagram to prove that. The first thing we're going to work out is the coin toss. Could either be a heads or it could either be a tails. Now, when you're drawing this diagram here, you always need to think of the second option. How many different options are in a dice roll? We know that the answer is 6. Okay? Now, if this needs to split off into 6 different lines, if you drew your tree diagram too small, you're going to have a lot of problems in the future. Another thing you'll notice is that I've drawn this line relatively straight. Alright? And the reason this is straight is because if we want our sample space at the end, and we want it to be a nice table, if these lines are all wonky and all over the place, like if I had a tree diagram that looked like that, and then I had numbers on the end like so, none of these will match up, and actually we're just going to make life hard for ourselves. So I know this is quite tedious to draw this as neat as possible, but when we then turn that into our sample space, you're actually going to be a lot better off in the end. And we can see the total number here is 12. So if we were to answer the question again, what's the probability of a heads and a 1? How many heads 1s are there? How many sample space do we have? So our answer is 1 in 12. Okay, so we're going to move on to the slightly harder questions. 4 candidates for a position of leader and deputy leader. We're probably going to pick the leader first and then the deputy leader after. So, with this question, however, we need to be smart because although Angus, Bridget, Connor, and Danielle can all be the leader, there is no chance that Angus can be both the leader and the deputy leader. Alright? So what we need to do is, instead of 4 more options, we are just limiting our next to 3 options, purely on the fact that our leader is not going to be the co-leader as well. So if we list out our sample space at the end, Angus and Bridget, Angus and Connor, Angus and Danielle, Bridget and Angus, Bridget and Connor, Bridget and Danielle, Connor and Angus, Connor and Bridget, Connor and Danielle, and Danny and Angus, Danny and Bridget, and Danny and Connor. So, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Sample space again is 12. Now, if we then answer the next question, what's the probability of Bridget being a leader or a deputy leader? In this example, is she a deputy? In this example, is she a leader? In this example, she's the deputy. In this example, she's the deputy. 1, 2, 3, 4, 5, 6. 6 out of 12. So the probability that Bridget is deputy or leader is 1 in 2. Now, before we continue, there's actually one more thing that's kind of helpful to know. especially if you're not confident in your tree diagrams being the best they can be. If we think about how many options are in this first event and how many options are in the second event, can you see how there's 4 options here and 3 options here? What's 4 times 3? 12. So our sample space is always the probabilities multiplied together. If we go back to the previous example, we had 2 options here, we have 6 options here. What's 2 times 6? Also 12. So when you actually have a set of probabilities, right, of 2 events happening at once, what you can do is just times them together to get what the answer of the sample space should be, and then as you're drawing your tree diagram, making sure you have an ordered tree diagram to then actually solve the rest of this problem. We've got one last question that we're going to do together, and that's this one here. So, the number of laptops sold in the past 2 weeks is shown below. There's brand X, there's brand Y, there's the total, there's week 1 and week 2. Now, the thing about this is that instead of writing brand X 80 times, we've just written the number 80 inside the box. So, of all the brand laptops sold, what fraction was sold in week 2? Okay, so here, our total, our sample space for all the brand X laptops is actually 130. The ones that were sold in week 2 is 50. So, the probability of brand X laptops in week 2 is found by doing 50 over 130. Now, girls, remember, in your calculator, you can cheat and simplify this without using your brain. Type in 50 over 130 and you will get 5 over 13. Alright, that is the simplest fraction we can make, and therefore we just need to do that. Question B, what percentage of all sales in week 1 was brand Y? So that means we're looking at week 1, that's our sample space. We're looking at all the ones that were from week Y. And so the probability of brand Y laptops sold in week 1 is 240 over 320, okay? Which equals to 3 over 4. Now the problem with this question is it asks for a percentage. So far we have a fraction. The easiest way to turn this fraction to a percentage is to times it by 100, and so we end up with 0.75 times 100, that's 75%. Alright, last question. During the 2 weeks, what's the probability that any laptop sold will be brand X? Now, in the first question we'll ask to make a fraction, in the second question we'll ask to make a percentage. It doesn't matter what your answer is. If you answer as a fraction, you'd be fine. If you just times this fraction by 100, you get the percentage, which is also fine. I'm just going to leave it as a fraction because I'm a little lazy. So what we do is we look at all the laptops that were sold in the 2 weeks. Our sample space is 520. We look at all the laptops that would be brand X, 130. So we're doing 130 over 520. And then when we type that into our laptop, and then when we type that into our calculators, we get 0.25, which is the same as a quarter, which is the same as 25%. All of these will give you full marks. Okay, so that's the end of this lesson. If you have any questions, then